Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on correlation in linear relationships. Please note as you watch this that students are required to have a table of critical values that tests the claim that the slope is not zero. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. This is part 2 of this PowerPoint or videos on this PowerPoint, and we are picking up where we left off and we'll pick up reviewing that last slide we looked at, which is the linear regression equation should only be used to make predictions if there is a linear relationship. To check for the linear relationship, we look at the scatter plot and visually verify that the data has a general linear trend. And step 2, if the absolute value of the R is greater than the table value, there is evidence of a linear relationship. Using the table this way, test the claim that the slope is not zero. If the absolute value of R is not greater than the table value, the data does not provide evidence of a linear relationship. Linear relationships have non-zero slopes. Notice that this involves 2 steps. And I went too far and started reading something else. Looking at the graph and then comparing your correlation coefficients to the table from your chart. Now, when we do the second steps, we are not concerned if the R is positive or negative, so we're only looking at the absolute value. We're ready for our example, and our 2 steps to remind us what they are at the top of the page. To start our example, we have 30 data points, and they are graphed and shown on our screen with a screenshot from our TI-83 calculator. The details on how to do this are on another video that you should be able to access. Step 1 asks us to look at the scatter plot and visually verify that our data has a general linear trend. And our data does have a general linear trend. For step 2, we use the calculator. Again, the steps of which in doing so are in another video. For now, we're just working on looking at the correlation coefficient and comparing it to our table value and deciding if a linear relationship exists. So here is the screenshot from the TI-83 regression. When we look at the screenshot, notice that it gives us the linear regression and our R and R squared values. Our R is negative 0.9607682864, which we will take and round to 4 decimal places, negative 0.9608. Our slope is at the top, and notice our slope is given as A and will be negative 10.4937. R is negative, slope is negative. The sign of the slope and the sign of the correlation coefficient are always the same. R is negative, slope is negative. If we drew the line through the graph, we would get this graph with the line going through it. So to finish our second step, we will need to get the table value from our table or chart. The absolute value of R just means that we're looking at R without its sign. So the absolute value of negative 0.9608 is 0.9608. And the table value from your table or chart, since there are 30 pairs, is 0.361. Is there evidence of a linear relationship? Yes. How do we know? Well, we know because, and we need to explain, we know because the scatter plot shows a general linear trend, and the absolute value of R is greater than the table value, and that means since both of those are true, there is evidence of a linear relationship. So since there is evidence of a linear relationship, we can make predictions using the linear regression equation. So that answer is yes. Let's do another example. We have our n equals 30, and for these examples, Ms. Borlaug is keeping some things the same. Notice that this is a different scatter plot. When we get our screenshot for the regression, we have different numbers. What is our R? Our R is negative 0.8345, and our slope is negative 9.7060. The sign of the slope and the sign of the correlation coefficient are always the same. R is negative, the slope will be negative. The line drawn through the points is shown, and so we have the three screenshots. So the absolute value of R, since R is negative 0.8345, the absolute value of R will be 0.8345. Looking at the table for a set of n equals 30 gives us 0.361 once again. Is there evidence of a linear relationship? Yes. How do we know? The scatter plot shows a general linear trend, and since the absolute value of R is greater than the table value, there is evidence of a linear relationship. Should predictions be made using the linear regression equation? Yes. Let's look at one more example. Again, remember the two steps that we will follow. Our n is equal to 30. Here is our regression screenshot. Let's find our R, which is negative 0.0124, again rounding to 3 decimal places, and our slope is going to be negative 0.0955. The sign of the slope and the sign of the correlation coefficient are always the same. R is negative, the slope is negative. We have a line going through our data, and the absolute value of R will be 0.0124, and R value at n equals 30 remains at 0.361. Is there evidence of a linear relationship? No. Explain how we know. Well, the scatter plot does not show a general linear trend. It appears that the slope is 0. And since the R value is not greater than the table value, there is not evidence of a linear relationship. The R value, or the absolute value of the R, is less than the table value. Therefore, there is not evidence of a linear relationship. Should predictions be made using the linear regression equation? No. And this is a good place to stop. We will pick up here in the next video. Again, thank you for watching.